This is the second video on inequalities in triangles. And in the previous video, we learned two theorems, which in plain English simply says this. The longer side will always be opposite the larger angle, and the shorter side will always be opposite the smaller angle, and vice versa. If you know an angle is larger, then you know that the side opposite is longer. There are two special cases in that case, in these problems, and that is when angles are equal. And the first one is called an isosceles triangle. And when you have an isosceles triangle, then you have what's called an isosceles triangle. Basically is when you have two equal angles or two equal sides. And there are two theorems with this. And the first theorem simply says this. I'm going to write these as pictures, we can also write them as words. The isosceles triangle theorem says simply that if you have a triangle with two equal sides, then that means that the angles opposite will also be congruent. And the converse of that is also true. If you have a triangle with two equal angles, then the sides opposite must be equal. So the first special case is that of an isosceles triangle. The common way the isosceles triangle theorem is written is that the base angles of an isosceles triangle are congruent. And the converse is often written if two angles are equal, or two angles are congruent, then notice the if-then structure. If two angles are congruent, then the sides opposite are congruent. This kind of makes sense if we think about it, but remember, the longer side is opposite the larger angle, the shorter side is opposite the smaller angle. It makes sense that if those two sides are equal, then the two angles are equal, and vice versa. The second special case is an equilateral triangle. If you have an equilateral triangle, then you have three equal sides. Then not only are all angles equal, which following the same reasoning would tend to make sense, right? And we also know that all angles are 60 degrees. How do we know that? Well, if we have a triangle with three sides are equal, that means we have a triangle with three angles equal, and we know all three add up to 180. And if you have three numbers which add up to 180, then each number must be 60. And that brings us to a new theorem. The next theorem we have is called the triangle inequality theorem. Now this theorem is fairly well known by name. And this simply says this. The longest side of a triangle is always shorter than the other two sides combined. It's not always written exactly in this form, but it always means the same thing. Let's have a triangle. Let's do this R-E-D. Then pick any side of these three triangles. Any single side will always be shorter than the other two sides combined. And that's simply the triangle inequality theorem. And let's try this out and see if we can do some problems with this. Can a triangle have the following side lengths? Let's go 5, 4, and 3. Well, to determine if you can make a triangle with these side lengths, this is what you do. You simply take the longest side, in this case 5, and add up the other two sides. The other two sides is 4 plus 3. So is the question is 4 plus 3 together larger than 5? And it is. So therefore you can't have a triangle like that. Let's do another case. Let's do 4, 9, and 2. Let's see what the longest side is. 4, 9, and 2. The longest side is 9. And is 9 less than 4 plus 2? 4 plus 2 is 6. 4 plus 2. 4 plus 2 is 6, and 9 is bigger than that, so this is not a triangle. If you think about why that's not a triangle, we could try to draw it. If you had a side length 9 and another side length 4, another side length 2, you can kind of see it. Even though I didn't measure these out, you can get the idea. These two sides wouldn't reach, the way you can think about it. Try a third example. Let's draw 6, 6, and 8. 6, 6, and 8. The longest side is 8. This is just an isosceles triangle. This is fine. Right? The longest side is 8, and the two other sides combined are 12, so that's yes. And a similar isosceles triangle problem would be 5, 5, and 1. In that case, the longest side, well, there's not a longest side. There's two longest sides, 5 and 5. But if you notice, both of them will be shorter than the other two sides combined. If you pick this one, 5 is less than 6. If you pick this one, 5 is less than 6. So this is yes as well.